Welcome. So in this video, we're going to go through question 4. Now I'm going to go through this very slowly. There's a quick way to answer this question, and I'm going to show you that quick way at the end, but I'm actually going to go through it very slowly, just so we can conceptualize what's going on here. So before we just jump into the answer. But once we understand it conceptually, when you are doing other questions like this, I want you to use the quick method. You shouldn't have to go through this long method to do it. But in this one, I'm just going to go through the very long way to do this. So it says, decide if the given points, so that's 2, 4 and 3, 5, lie on the graph with the given rule. So my rule here, the given rule is y equals 2x. So because we're going to conceptualize this, let's actually create a table of values for our given rule. So our given rule is y equals 2x. So we're going to create a table of values for this, and that's going to help us plot it. So think, what does this mean? We want to be able to plot this. So we want to say, all right, when x is equal to 1, what is my y going to be equal to? When x is equal to 0, what is my y going to be equal to? That's what we're going to try to find now. So let's say we start with x is equal to 0. Well, when x is equal to 0, what is my y equal to? And remember, to do this, what you do is you go sub in x is equal to 0. So I'm going to get y is equal to 2, 0. That means 2 times 0. So y is equal to 0. So that's a 0 there. So that means when I put x in, I get 0 out. So think of this also. We can write this as a coordinate. This is the coordinate 0, 0. So that's right here. That's our first point. Let's now do another point. Let's find out what my y value is going to be when I sub in x is equal to 1. So I'm going to go sub in x is equal to 1. That's going to be y is equal to 2, 1. 2 times 1 is 2. So my answer will be 2. So when I put 1 in, I get 2 out. And remember, this is a coordinate. This is the coordinate 1, 2. So I'll come down here. I'm going to go 1, 2. It's going to be here. And then maybe you want to do, let's keep on going. Let's do 2 actually next. Let's find what is my y value going to be when I sub in x is equal to 2. So I'm going to go, all right, sub in x is equal to 2, y is equal to 2, 2, y is equal to 4. Because 2 times 2 is 4. So that's going to be 4. And remember, this is a coordinate. So this is the coordinate 2, 4. Then we come down here. I can graph that. That's going to be 2, 4 right there. And we can also go backwards as well, can't we? We could say, well, what's it going to be when x is equal to -1? So that means I'm going to go sub in x is equal to -1, y is equal to 2, -1. 2 times -1 is -2. So that means I'm going to go, when it's -1, I get -2 out. -2 out. And you can keep on going on this. So for instance, if I have -2, well, if I sub -2 into this, -2 times 2 is -4. So that's going to be the point what? It's going to be the point -2, -4. So it's going to be -2, -4. It will be here. I could do -3. What's 2 times -3? It's -6. Then I can plot that. -3, -3, -6. What if I put 3 in here? Well, if I put 3 in there, I'm going to get 2 times 3 is 6. So it will be up here. And what if I put 4 in here? Why not? Oh, sorry, I have to put a 6 there, don't I? 3, 6. If I put 4 in there, 4 times 2 is 8. So this will be 8. Whoopsie daisy. 8. 4, 8. So I'm going to get that. I can now, as you can see here, it creates a line, doesn't it? It creates a line, and I can draw a line through this. So I'm going to try my best to draw a line that's going to connect all these things together. And remember, this line keeps on going. Now, hopefully you have a ruler, because otherwise it's really quite hard to do this. Keep on going, keep on going. It's going to look something like that. And remember, this line keeps on going on and on. Because if I was to say, well, what's going to happen when I let x be equal to, I don't know, 7. Well, it's just going to be I go y is equal to 2x. I put a 7 in my x spot. Y is going to be equal to 14. So when I get 7, Now that my y-axis doesn't go high enough, but it would be up here, wouldn't it? And my line would keep on going. But we don't need to worry about that. Perfect. So we've created our line. Now, this isn't what the question has asked us to do, but it's going to help us conceptualize what's going on now. Because now the question says, the most important part, does 2, 4 lie on the graph? So my graph here is my straight line, and it should be much straighter than this. It should be perfectly straight. But it's asking, does the point 2, 4 lie on the graph? Well, let's find the point 2, 4. Here's 2, here's 4. This is the point 2, 4. And let me write this a bit smaller. That right there is 2, 4. So does the point 2, 4 lie on the line? In other words, is it a part of the line? And the answer is yes, it's lying on the line. It's on top of it. And you can see that conceptually by looking at what we've just created. But did we have to actually draw it to check whether or not this is true? And we didn't, because what we could have just done is the following. We could have said, what this is telling me right here, is it's telling me that, hey, when I let x equal 2, my y is going to be equal to 4. And we can check whether that's true. We can say, let x be equal to 2. I know that my rule is y equals 2x, so I'm going to go y equals 2, and then into my x bar I'll put 2. 2 times 2 is 4. So that means when x is equal to 2, y is equal to 4. And as you can see, that's what we were told. So that's how we know, yes, this is true. So the answer to this one is yes, it does lie on the line. What about this one? What is this one saying? This is saying when x is equal to 3, y is equal to 5. Well, is that true? Well, we can look at graphically first. We can say, here's 3, here's 5, so it's here. Now, as we come and look here for a second, ignore my poor line, but does this point here, 3, 5, is it on the line? And it clearly isn't. It isn't on the line. It's not touching it. But we didn't have to do this graphically. We could have tested this out algebraically, or not algebraic. We could have tested it out by subbing in values. So we could say, all right, let x be equal to 3. And what this is telling me is that, well, when I let x equal 3, does it equal to 5? Well, if I do that, I get 2, and into my x bar I'm going to put 3. So that means I'm going to get y is equal to 6. So that means the point here is actually 3, 6. When x, because remember, this is my x value, and this is my y value. So when x is equal to 3, y is equal to 6. So this isn't true. When x is equal to 3, y doesn't equal to 5, it equals to 6. So this is no, it doesn't lie on the line. And you can see that graphically here as well. Do you see how it's not on the line? It's over here, it's not on the line. You can also see how this is true by looking at a table of values. Do you see how you've got 2, 4 here? And that's true, 2, 4. And here you got 3, 6. So not 3, 5, 3, 6. It's not on the line. Now, as I said, this is the long way to do this. The far quicker way to answer this question is just to do this method right here. So if you were to do this question quickly, you would just do this. That's what you would do. You wouldn't draw it. You wouldn't write out the table of values. All you would do, if we were to do it again, is this. You'd go, all right, this is telling me that when x is equal to 2, y is equal to 4. You would say, let x be equal to 2. You would sub that in to this, y is equal to 2, 2. Then you'd go, all right, this is y is equal to 4. Well, look at that. When I have 2, I get 4 out. And remember, this is my x value. This is my y value. So that's true because it's on the line. But over here, again, this is the quick way to do it. You would just say, all right, this is saying that when x is equal to 3, y is equal to 5. Well, is that true for my rule? Is it lying on that graph? Well, you'd say, well, let x be equal to 3. You would sub 3 into the rule, and you'd get 6 out. And that means that we get the point 3, 6. Because remember, this is my x value, and this is my y value. Well, 3, 6 is not 3, 5. So the answer is no. This line goes through 3, 6, not 3, 5. Hopefully this makes sense. If you're still sitting there and you're like, I still don't get this, Mr. S, you're going to have to explain it another way. Let me know and we can go through it another way in class tomorrow. And I'll go through another example of this. I'll do another recording and hopefully that will help as well. But give this a good watch. And then if you're still struggling with it, we'll talk more about it tomorrow. It's a new idea. It's a fresh idea. So don't panic if it's all a bit new to you. All right. I'll see you in the next video and in class.